There you see again the key speeds and feeds of the N6000 models, and you can see how they contrast to the previous generation of N5000 models. Pretty much greater scalability throughout, greater performance from the upgraded hardware throughout. Finally, we get to the high end of the product line, which is the N7000, which is now in its second generation. This is meant to scale to much more massive capacity and performance requirements that you might have in your environment. It's basically fairly close to what you see in the N6000. It's a modular system with the integrated I/O. It occupies 12U with its chassis, 16 fiber channel and 12 gigabit Ethernet on board, and then that can be scaled out with additional adapters to expand your ports up to 48 fiber channel ports and 52 gigabit Ethernet ports. And then in terms of storage scalability, over 1,000 terabytes of capacity and over 1,000 spindles of fiber channel or SATA disks. There you can see the two models at the high end of the product line, the N7700 and the N7900. Pretty much linear scalability from one to the other, 32 gig of memory versus 64. Otherwise, pretty much the same kind of hardware. Max spindles on the 7700, topping out at 840, and then over 1,000 on the N7900. As you can see, pretty much the only real differentiators between the product line at the hardware level is as you scale up in hardware, you get more performance, you get more scalability from a disk perspective. And of course, price scales as you invest in more powerful infrastructure. All the software features, all the multi-protocol capabilities, all the virtualization capabilities are pretty much the same in terms of capability throughout the product line. Price for those features is dictated based on the tier of hardware you're at, and that's really where the cost model comes in with N-series versus other storage devices you may be familiar with. Rather than being charged per terabyte as you scale up in capacity, they do it more on a tier basis based on the hardware tier you're at, and then specific features have specific costs. All this is tied together by the unified operating system that the N-series runs across the product line. NetApp calls it Data on Tap. It's their own unique operating system. Many years of dedicated development just for running a storage appliance. And this is their key differentiator. They put a lot of development effort into Data on Tap operating system and giving it all these specific software capabilities to enhance specific features for specific needs. Underlying all that is, of course, again, the multi-protocol support. That's really the key offering for the NetApp across the line. Native access to common files, especially in a NAS environment for Windows, Unix, and Linux. Windows users will see CIFS, which is the protocol they want to see. Your Unix users will see NFS, which is the protocol they want to see. This can get you some capacity savings. In your traditional environment, you go keep each operating system in its own sphere. You'd set up maybe a file server for doing Windows file shares, a file server for doing NFS mount points, and you'd have to set up separate pools of capacity to meet those different needs in those separate environments. In NetApp, you now have an appliance that can service both environments from a single pool of storage, and you can yield significant space savings by leveraging those capabilities. NetApp uses a unique RAID system that they developed for their storage systems. It's really optimized by their Data on Tap operating system to yield equal or and sometimes better performance to what most traditional storage systems do. Most traditional storage systems do what's known as RAID level 5, which is single parity RAID. Single parity RAID basically stripes your data and stripes parity data across a certain set of spindles, and usually you get about one disk's worth, one spindle's worth of parity data kept. What that protects you from is that protects you from a failure of up to a single disk spindle. When a single disk spindle fails, you have to rebuild it. If you suffer another failure, then you're going to start entering into a data loss scenario. With NetApp, what they decided to do, especially since they wanted to offer adequate protection for your more commodity serial 88 drives, which are much higher capacity, so your odds of failure start to go up as you get much denser in your storage per spindle, as well as your rebuild times on RAID start to go up as well. The way they decided to address it is they decided to do a dual parity RAID, which some circles call it RAID 6 versus RAID 5. They just call it RAID dual parity. And what they basically do is they dedicate an extra spindle's worth of storage for storing parity data, so they can now tolerate up to 2 spindles going down without any data loss. And they found that through the optimization they do with their data on-tap operating system, they can get equal and sometimes even better performance versus traditional RAID 5 using this RAID scheme. And it gives you better protection than traditional RAID 5, which only has that single parity worth of single disk worth of parity information and can only tolerate a single spindle loss. Software options are really where NetApp and IBM N-Series see their key